Hello all. Today we'll be studying about assembler, compiler, interpreter, linker and loader. All these are assembly language programs that helps in the execution of a program. Now first of all we should study about assembler. What the assembler is. Assembler takes assembly language program as an input and provides object program in the form of machine language. Here one of the example has been given, that is assembly language instruction, and it is add 49. The output of assembler will be a binary code, as computer is a machine which understand the instruction in the form of 1 and 0. So add is being represented in the form of a specific binary number, and the corresponding binary number of 4 and 9 is also being provided by the assembler. This is an example of addition of two numbers. In the same way, multiple operations will be supported by the hardware and corresponding opcodes will be available. So in case of assembly language, there are different mnemonics available and all the mnemonics represent a particular opcode. The major drawback of assembler is it is machine dependent. The number of registers supported by the given machine should be known, then only we will be able to write the assembly language program for that particular hardware. Now we come over the compiler. This compiler takes source program as an input and provide target program as an output. This source program can be any high-level language, while the target program can be any high-level language program, assembly language program, or machine language program. The compiler also provides error messages that are present in the source program. The compiler executes slower as compared to the assembly program. It converts the entire source program in one go, or it can work in multiple passes. Now we come over the interpreter. Interpreter interprets the source code line by line. At the same time, input data is also provided. So whenever a line is interpreted, input data is also applied on the given line and we get the corresponding output. So it translates the program line by line and it provides the faster response. But as it is executing the program line by line, so it will be time consuming. Let us compare compiler and interpreter on the basis of some comparison parameter. Here multiple comparison parameter has been given, such as input, output, working mechanism. So let us take them one after the other. First of all, we should consider the input, the type of input provided to the compiler and interpreter. Compiler takes an entire program as an input at a time, while interpreter takes a single line of code or instruction at a time. The output of the compiler is an intermediate object code, while interpreter does not produce any intermediate object code. If we come over the working mechanism, the compilation is done before the execution, while in case of interpreter, execution and compilation both takes place simultaneously. If we consider the speed, compiler is much faster than interpreter. If we come over the memory requirement, so compiler needs more memory as it will be allocating full program as compared to the interpreter. Now we come over the way in which error is being displayed. Compiler will display all the errors after compilation at the same time, while interpreter will display error of each line one after the other. There are different programming languages that support compilation, that is C, C++, C hash, etc. While many programming languages supports interpretation, that is Java, PHP, Perl, Python, etc. Now we come over the linker system program. Linker works as a merger which merges different object files. there are different object files generated by different programs, and in our program we also use some subroutines that are being already provided in the library. So the task of merging is being performed by the linker. The basic task performed by the linker is to search the program to find the library routines used by the program, then determine the memory location that code from each module will occupy and relocate its instruction. And it also resolves the reference among the files. This diagram shows the basic task of linker, as it is merging different object files generated after compilation or interpretation, and it also merges it with the runtime library and generates one executable program. Now we come over the loader. Loader is a part of the OS. The main task of loader is to load the executable file into the main memory. But to load the particular file into the main memory, one should know the size of the file. So the loader reads the file's header, and from that file header it comes to know about the size of the text and the data segments that is being present in that file, and it create a new address space for that program and copies the instructions and data into the address space. To execute a program, first of all, machine registers should be initialized. So the same task is being performed by the loader. Loader will load the program into the main memory, and it will initialize the machine registers, including the stack pointer, and call the program's main routine. This is a general loading scheme that program A and B are needed to be loaded into the main memory. So loader will load them according to the memory freely available and the size of the programs. Thanks for watching my video. Your feedback will be valuable for me. Thank you.